Welcome to Maths with EJD. This is my third video on complex numbers, and we'll be discussing multiplication and division of complex numbers. In the last video, we started with the operations on complex numbers, and we looked at addition and subtraction of complex numbers. So here, let's take it further as we look at these very important ideas of multiplication and division in the context of complex numbers. So here we'll be looking at multiplication of complex numbers, what that is about, and then we move on to conjugate of a complex number because that is necessary for division of complex numbers, and then we make a conclusion on the process. So having said that, let's see what we have here. So talking about multiplication of complex numbers, right? It basically follows something close to what we have in real numbers. So multiplication of complex numbers generally follows the same rules for real numbers, with emphasis on the fact that I squared is the square root of -1 squared. You know, we already know that I is the imaginary unit when we introduced the idea of complex numbers in the first video on complex numbers. So we discovered that complex numbers came about because we started to represent square root of -1 with I. So when you square I now, when you square I, that is square root of -1 all squared. You already know that square is the inverse of square root. So square cancels out square root. So I squared is equal to -1. So that's one big deal to pay attention to when we do multiplication and division of complex numbers. As such, the product of these complex numbers now, which is Z1, which is A plus BI, and Z2, which is C plus DI, will be defined as follows. You have Z1 times Z2, and that is A plus BI multiplied by C plus DI. Okay, so we just follow normal multiplication rules. This is key, like we said. So A times C, AC, A times DI, ADI, BI times C, BCI, then BI times DI, that is BDI squared. Very important. And then you don't forget that I squared is -1. That's the key thing here. So I squared is -1. So that's why you now have, of course, the normal AC plus ADI plus BCI. Then BDI squared is now minus BD because I squared is -1. So -1 times BD is minus BD. So we tidy that up to have AC plus ADI plus BCI minus BD. Plus times minus is minus. So what we now do is to collect like terms with the imaginary unit and terms without the imaginary unit. Talking about terms without the imaginary unit, we have AC minus BD. So that's why we have AC minus BD. That'll be the real part here. And then we have ADI plus BC. That's AD plus BC. Then I binds them together. So that is the imaginary unit. So we have the real and the imaginary like that. So that becomes like some kind of rule that whenever you are multiplying two complex numbers, so you have A times C minus B times D like this, and then A times D plus B times C that way. So of course, if you are very good with memorizing formulas, that will be good, especially if you're in a very if you have to work very fast. But if not, then you can easily expand like this and derive your result as we have right here. Okay, so let's see an example that we can try our hands on. So Z1 equals 2 plus 3 and Z2 equals 1 minus 2i. We are given those. So their multiplication will be Z1 times Z2, which is 2 plus 3i multiplied by 1 minus 2i. So you just follow the same procedure like I explained. 2 times 1, 2. 2 times minus 2i, that's minus 4i. 3i times 1 plus 3i. 3i times minus 2i, that is minus 6i squared. Minus 6i squared. All right. And then we know that, of course, this is 2 minus 4i plus 3i. So I squared is -1. So -1 times 6 is -6. Apart from the minus that was already outside here, right? So we take it further. We have 2i minus 4i plus 3i. Minus and minus is now plus 6. Then we collect like terms, terms without the imaginary number, the imaginary unit I. We have 2 plus 6 plus terms with the imaginary unit minus 4 plus 3 into I. And then we tidy all that up. And then we have 2 plus 6, 8, minus 4 plus 3, that's minus 1i. And that goes. So you can see that that's just it. So if you do Z2 times Z1, you will get the same 8 minus I. And that is why this particular conclusion is reached. It is important to note that Z1 times Z2 is the same thing as Z2 times Z1. So you can say that even multiplication of complex numbers is commutative. You know, I think if we talked about commutativity, when we talked about multiplication of matrices, that AB is equal to BA. You know, it's not, so not all operations are commutative like that. As we are going to see, division, whatever you start with, you are going to get different results if as far as they are not the same. So let's try our hands. These are practice questions for multiplication of complex numbers. So it's a practice question. Find the product of 3 plus 2i and 1 minus I. And of course, you know, the product is the result of multiplication, right? And then multiply minus 2 plus I and 3 minus 4i. Then evaluate minus 3 plus 7i multiplied by 5 minus 6i. So you can just simply try your hands on those and get very beautiful results from that. Okay, so with that, we move on to the concept of division of complex numbers. So, okay, before we do that, we go to conjugate because we need the idea of conjugate when we talk about division of complex numbers. So the conjugate of a complex number, z equals a plus I, the conjugate of this complex number, z equals a plus I, is denoted by bar z, you know, bar z, and that is defined as z equals a minus bi. Actually, this should be bar z equals a minus bi. All right, bar z equals a minus bi. So what simply happens is to get the conjugate of a complex number, just change the sign in the center, that's all, and you automatically get the conjugate. So the conjugate is what makes it, if you multiply any matrix by its conjugate, you get a scalar number. So anytime, for instance, now you have, it's more like you have a plus bi multiplied by a minus bi. Anytime you do this, you always get a squared plus b squared, because you know a times a is a squared, a times minus bi is minus minus abi, bi times a is plus abi. So this will cancel out. So you have bi times bi, that should be plus bi squared. That will be okay. So plus times minus, that's minus bi squared, and I squared is minus 1. So minus bi minus b times minus 1 is plus b squared. So if you want to turn a matrix into scalar, you multiply by bi. Okay, so that's the idea of conjugate. Just change the sign and you get the conjugate. And don't forget that this is actually bar z, and that is a minus bi. That's the conjugate to a plus bi. So if that is the case, then we can say that, for example, the conjugate of zi equals 2 plus 3i and z equals 1 minus 2i are this. So for z1, 2 plus 3i, z1 bar will be 2 minus 3i. For z2, 1 minus 2i, the conjugate to be z2 bar equals 1 plus 2i. So just change the sign in the center and you get the conjugate. Very simple concept right there. Okay, so with this idea now, we have what we need to take care of division of complex numbers. So division of complex numbers is defined as multiplying the numerator by the conjugate of the denominator. You see why we needed to learn conjugate. So multiplying the numerator by the conjugate of the denominator and dividing by the absolute value of the denominator squared. So you see that this is a very summarized way of talking about the division of a complex number. So you have complex number z divided by z1 divided by complex number z2. That's simply the same as multiplying z1 by the conjugate of z2, and then at the bottom you just square, you know, what you get when like what we just did. So if you have a plus bi multiplied by a minus bi, you know, we already know that is the same thing as a squared plus b squared. If you expand, it's a squared plus b squared. And this is actually the same thing as the absolute value of a plus bi, because the absolute value of a plus bi is simply the same thing as the square roots, the square roots. So this is the same thing as absolute value raised power 2, actually. So that's the square, this, and the absolute value of a plus b is actually square root of a squared plus b squared. But by the time you square it now, this cancels out. So you end up getting your a squared plus b squared. That's what the division is about. But then, I mean, it may not be that. You don't always have to memorize that, but that's the definition. If you want a very cute definition for it, that's it right there. But then you can always just do the work and you get what exactly that is talking about. Okay, so here now, the whole idea of division of complex numbers can be summarized in the keyword rationalization. So you rationalize, and to rationalize a matrix is to multiply it by its conjugates. So for complex numbers, z1 equals a plus bi and z2 equals c plus di, division is given by rationalizing the ratio using the conjugate of the denominator as follows. So you have z1 over z2. So z1 is a plus b1, z2 is c plus a plus bi, and z2 is c plus di, like this. So for you to work this out, you need to check the denominator, that is c plus di. So if it is c plus di, then the denominator is c minus di. All right. So, and what is going to happen is it's more like you're saying a plus bi all over c plus di multiplied by 1. I mean, we did this a lot under basic calculus. Like when you need to get something and the thing is not available, so you find a way of multiplying by 1, and then 1 can be anything. So 1 can actually be here, c minus di all over c minus di. Carefully chosen, c minus di, right? Carefully chosen because c minus di is the conjugate of c plus di. And that is how we rationalize, when we are dividing matrices. So, and to rationalize that, that's how we begin to move. So we have a plus b1 all over c plus d1 times, this is as good as 1, and anything multiplied by 1 it has not changed, right? It hasn't really changed. But then you have achieved your purpose of moving on. So what do we do now? So we have a plus bi multiplied by c minus di all over c plus di multiplied by c minus di. We already know that multiplying a complex number by its conjugate will give us a scalar number at the end of the day. All the i's will be gone at the end of the day when we multiply a complex number by its conjugate. So again, let's go. A times c, ac, a times minus di, that's minus adi. Bi times c is bci. Bi times minus di, that's plus bd. I believe you have understood now, because plus bi times minus di is actually minus bdi squared, okay? Minus bdi squared. And that means you have minus I squared again is minus 1, as usual. So that's minus 1 times bd. So that's why we have plus bd. So that's me jumping all that step because I believe you have understood now, So I have bi times minus di, bi times minus di, that's minus bdi squared. I squared is minus 1. So minus bdi squared, that's minus bd times minus 1, that's plus bd taken. And then when you come to the bottom, just to expand this, I won't always do this. I mean, just to show it this time. So c times c is c squared. C times minus di is minus cdi. Di times c is plus cdi. Then plus di times minus di. That should be minus di squared. I squared is minus 1. So that's why this becomes plus plus d squared. All right. So, and it's actually clear from there that minus cdi and plus cdi will cancel out. So at the end of the day, you have c squared plus d squared left at the denominator. And then for the numerator, you collect like terms, ac plus bd. You have that. And then for I now, just to have plus coming first. So you have BC minus ADI. So this is actually what the expression looks like. And then you can divide each through the real part and the imaginary part through by the c squared plus d squared, which is a scalar value now. So that's why you end up having AC plus BD all over C squared plus D squared, and BC minus AD all over c squared plus d squared, then I. So this is the imaginary part, this is the imaginary unit, and this is the real part. That's how to go about division. You just rationalize. So let's take practical examples. So given that zi equals 2 plus 3i and z2 is 1 minus 2i, the question is to find z1 over z2. So z1 over z2 will simply be 2 plus 3i over 1 minus 2i. And then we know to rationalize, we multiply by the conjugate of 1 plus 2i. And then that's like this divided by this is simply multiplying by 1. So, and if you multiply by 1, you have not done anything wrong, okay? So you have 2 plus 3i multiplied by the conjugate of the denominator. And then you have 1 minus 2i times the conjugate of the denominator. So again, as you already know, so 2 times 1 is 2, 2 times 2i is 4i, 3i times 1 is 3i, 3i times 2i is 6i squared, and I squared is minus 1, so you have minus 6, okay? Then, of course, for the denominator, you already know the answer is going to be 1 squared plus 2 squared at the end of the day, so you have 1 squared plus 2 squared. So it's like, it's like difference of 2 squares again. So 1 minus 2i into 1 plus 2i. It's like it's coming from 1 squared minus 2i squared. That's like 1 squared minus 4i squared. And I squared is minus 1. So you have 1 squared minus 4. All right. Which is 1 plus 4. And that is 5. Right? That's why in summary, it's simply 1 squared plus 2 squared as we have here. So this is 5 at the end of the day, right? Okay. So you can always do that instead of wasting time trying to expand. So just pick 1, square it, pick the first number here, square it, plus 2, the other number, whatever it is, just square it, and then you're good to go. All right. So with that taken care of, we have 2 minus 6, that's minus 4. 4i plus 3i, that's 7i. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. So we can now break it down into real and imaginary parts. So we have minus 4 over 5, that's what we have here. And then we can also have 7 over 5i, 7 over 5i, that's the imaginary part. So we have the real part and the imaginary part. And that is how to go about division of complex numbers. Okay, so now what we did there was z1 over z2. So now let's talk about z2 over z1, z2 over z1, if you like. So again, z1 is 2 plus 3i, z2 is 1 minus 2i, and we're now looking for z2 over z1. Okay, so now z2 is 1 minus 2i, z1 is 2 plus 3i. Then we do the same thing. Check for the denominator, it is 2 plus 3i. The conjugate is 2 minus 3i. So you multiply the top and the bottom by the conjugate so that it will give something like you're multiplying by 1. So you have 1 times 2, 2. 1 times minus 3i, minus 3i, minus 2i times 2, minus 4i, minus 2i times minus 3i. That is plus 6i squared, plus 6i squared. But I squared is minus 1, so that's why it becomes minus 6 like this. That becomes minus 6 that way, minus 6 here. And then for this, just say 2 squared plus 3 squared, whatever it is, whether it's plus or minus, just say 2 squared plus 3 squared. Because when you expand, that's what you get. So now you have 2 minus 6, 2 minus 6, that's minus 4, minus 3i plus 4i, that's minus 7i. And then you can say that is minus 4 over 13 for the real part and minus 7 over 13 for the imaginary part, minus 7 over 13i. And from that now, you can see that z1 over z2 gave you minus 4 over 5 plus 7 over 5i. Now this is giving you minus 4 over 13 and a 7 over 13i. So you see that z1 over z2 is not equal to z2 over z1. So it means that division of complex numbers, just like division for real number, is also not commutative. The results are different. So that's really important to take note of. So gradually coming to the end, let's see what we have here. So you have some practice questions right here. to try your hands on. So because of the lack of commutativity, you have so many things to do here. So find A, for instance, 5 plus 4i over 1 minus 2i, and B, 1 minus 2i. I mean, just changing it over. So same for the other ones, 3 minus I over 2 plus I, and then B, 2 plus I over 3 minus I. Same for this, minus 3 minus 2i over 2 minus 3i, then 2 minus 3 over minus 3 minus 2. So you have a lot to deal with. And in conclusion, just a summary or so of the things we have done. So you just know that complex number multiplication is actually complex number multiplication and division follow specific rules, just like what we have for real numbers. And then the things to pay attention to here is that I squared is equal to -1, and Z1, Z2 is the same thing as Z2, Z1, whereas Z1 over Z2 is not equal to Z2 over Z1, that as you have seen. So by understanding these rules and practicing, one can become proficient in manipulating complex numbers. So that's the idea at the end of the day. So this is pretty simple. The concept of complex number is really simple, but it has very powerful applications as we we'll see as we continue to explore. So if you have not subscribed to my channel, please do that so you don't miss out on these juicy videos that will be coming your way. Don't also forget to hit the the notification bell so you can get alerted each time I release a new video. Thank you so much for always coming by. See you in the next video.